Hi students, today we are going to solve the problem in chapter 13. Before moving on to the problem, let's have a brief intro about the formulas we are going to use. First we can see the surface area of a cuboid. As you all know, for a cuboid having length L and breadth B and height H, we'll have a pattern like this. For example, when you unfold a gift box or a cotton box or a sweet box, you'll get a pattern like this. That is, it will consist of 6 rectangular faces. So to find the surface area of a cuboid, you have to add up all the areas of the 6 rectangles. That is, area of rectangle 1, area of rectangle 2, area of rectangle 3, area of rectangle 4, 5 and then 6. So now consider here, for the first rectangle, the area will be length into height, and for the second rectangle the area will be length and breadth. For the third rectangle it will be length and height. See, ln h, ln b and ln h. And for the fourth rectangle again it will be length and breadth. In the fifth rectangle it will be breadth and height. For a sixth also it will be breadth and height. So when you add up all these things, you will get each product twice. For example, the product L and H will be twice. There are 2 times there. And the product L and B is also 2 times. And the product B and H is also 2 times. So when you are taking 2 outside, you will get 2 into LB plus BH plus LH. That's the formula for surface area of a cuboid. Now see the formula for lateral surface area of a cuboid. To derive this formula, you have to consider only the lateral sides. That is, imagine a cotton box that doesn't have a top and a bottom. So considering this pattern, the 2 rectangles 2 and 4 will not be included. So now we have to find the lateral surface area of a cuboid only with the areas of the 4 triangles. That is, area of triangle 1, area of triangle 3, area of triangle 5 and area of triangle 6. That is L into H, L into H, B into H and B into H. So it's 2 times LH and 2 times BH. When you take 2 and H outside, you will get 2 into L plus B into H. Let's move on to the cube. If the length, breadth and height of the cuboid is equal, then it will become cube. That is, all the sides will be equal. Now let's consider the length as A for one side. So if you unfold that cube, you will get the pattern like this. So for when you consider a single square, the area will be A square. That is A into A. So for the surface area of the cube, you have to add up all the areas of all the 6 squares. That is, finally you will get 6A square. For the lateral surface area of a cube, you have to cancel out the top and bottom face. So totally it will be 4 squares. You have to consider only the 4 squares. It is, the upper one is cancelled and the bottom one is cancelled. So the lateral surface area of a cube will be 4A square. Now we'll move on to the question number 1 in the exercise 13.1. A plastic box 1.5 meter long, 1.25 meter wide and 65 centimeter deep is to be made. It is opened at the top. Ignoring the thickness of the plastic sheet, determine the area of the sheet required for making the box. And the second one, the cost of sheet for it if a sheet measuring 1 meter square at ₹20. So first we have to see the details what are given. Length of the box be 1.5 meter and breadth of the box is 1.25 meter and height of the box is 65 centimeter. Now here the length and breadth are given in meter, but the height is in centimeter. First we have to convert this into meters so we can have a uniform unit. We know that 1 meter is equal to 100 centimeter. So to convert it into meter, we have to divide the 65 by 100. So you'll get 0.65 meter. And you have to consider the condition that it is opened at the top. That means the box is a open box, that is the face 4 will not be considered. Here the top what will not be considered. So to find the area of the sheet required for making the box, you have to consider only the 5 rectangles. That is rectangle 1, 2, 3, 5 and 6. So now let's move on to the solution. So for the first division, you have to find the area of sheet required to make the plastic box. So for that, you have to consider the surface area of the cuboid. As we all know, it is the addition of all the areas of 6 faces. That is, this is for phase 1, this is for phase 2, and this is for phase 3, and this is for 4, and this is for 5, and this is for 6, as we discussed earlier. Now the box is open, so the phase 4 will not come. So you should not include in the area calculation. So now we have to include only 1, 2, 3 and 5 and 6. When you simplify this, you'll get 2 LH terms and 2 BH terms. So taking 2 outside, you'll get 2 LH plus BH. And separate one L into B. So this is a portion. Now we have to substitute the values for length, breadth and height. So the length is 1.5 and the height is 0.65 and the breadth is 1.25 and the height is 0.65. So now when you multiply 1.5 and 0.65, you'll get 0.975. When you multiply 1.25 and 0.65, you'll get 0.8125. When you multiply 1.5 and 1.25, you'll get 1.875. Now within the square bracket, you have to add up. That is 0.975 plus 0.8125, you'll get 1.7875. And when you multiply with 2, you'll get 3.575. Now add up the 1.875. And adding these two, will get 5.45 meters square. You have to mention the unit always. So finally, you will get the area of sheet required to make the boxes 5.45 meters square. So now let's move on to the second division. In this, we have to find the cost of sheet for making the box. It's already given. The cost for 1 meter square sheet is rupees 20. So to get the cost of sheet for making the box, you have to multiply the area of the sheet required to make the box and the cost per meter square of the sheet. As earlier, we have found the area as 5.45 and the cost per meter square is 20. When you multiply these two, you will get 109 rupees. Finally, you will get rupees 109 for making the box. That's all for now, guys. We'll catch up in the next video.